Another kind of transformation that we can perform on these functions is a stretching and compression. So if g of x equals a times f of x, where a is greater than 1, then we are stretching f. To get g, we're stretching f by a factor of a. So like if a is 2, then we're stretching f by a factor of 2. So what that means is every y value will be twice as high. If a is 3, it'll be 3 times as high. If a is a half, it'll be 1/2 as high. But that's called compression. So h of x equals a times f of x with a between 0 and 1. This compresses compresses f vertically by a factor of a. So if a is a half, all the y values for h will be 1/2 of the y values for f. So here's an example with just a simple graph, the one we used before. So this is f of x, and you'll see if I draw g of x, it's not shifting it up 2, although it might look like it from the horizontal lines. But notice that the slanted line is steeper. It's actually slope 2, whereas for the g function and for the f function, it's a slope 1. So this is steeper here than this is here. So what's actually happening, I just decided to go on its own there. What's actually happening here is this for this 1, the first coordinate 1, the output is at 2, whereas the output for f was only at 1. So it's twice as high, right? Output 1, output 2, because of the 2 coefficient. Output 2, output 4, 2 times 2. And then if, for the second case where the coefficient is between 0 and 1, it compresses f vertically. So here's f, it compresses it. It shrinks it towards the x-axis. So y coordinate 1, x coordinate 1 becomes x coordinate 1, y coordinate a half. X coordinate 2, y coordinate 1 becomes x coordinate 2, y coordinate a half, right? X coordinate 3, y coordinate 2 becomes x coordinate 3, y coordinate 1. Okay, so notice the x coordinates aren't affected, it's the y coordinates. So that's stretching and compression.